What is up, Precal12? It is Coach Jay here with you, and I'm doing these podcasts as a just in case for if I am absent from school. For my wife right now, she currently has not had the baby, and I do plan on being there with you, but just in case, that's why we're going into these podcasts today. So today's podcast is actually over both sections 4.3a and 4.3b. And it's actually not 4, I'm sorry, 7.3a, 7.3b. And we're going to take a look at some things involving systems of equations as we wrap up this unit. Remember, too, that if I miss one of the days of 7.3, to remember that on block day, we have the review. And then finally, on Friday, we have our test that's over both sections 7.1, 7.2, and 7.3. So just as a reminder there, I wanted you to just kind of be ready and prepared, and we'll get it and go. So without further ado, sit back, watch, take out your homework, take out your notes. The substitute should have given it to you. If you've just missed class and you're watching it today, I hope this is of help to you as we go through our last new section of the year, of the calendar year. So here we go. All right, so when we talk about systems of equations, many times we've talked about two systems of equations, right? We've done that where we have x and y, and we used elimination and methods of substitution in order to solve for the missing variables. And that's kind of what we're using here. Now, the only thing different about section 7.3 compared to section 7.1 and 2 is that now no longer do we have two systems of equations, but now we actually have three. Now, in utilizing these systems of equations, you almost have to work backwards and see, all right, what have they given to me, and how can I simplify this going forward? Now, the good news is that many times there's only really one additional step from three systems of equations to two, and that's eliminating one of these three and going from three equations to 2. So how can we get it from 3 to 2? Now, with this first one, you'll notice that if you're following me on your notes, the first value, z equals 2, makes it easy for us because we could simply plug it into the top where z was 2 to get y plus 3 times 2 equals 5. Well, you'll recognize that as we plug it in, we now have one system of equation with one variable. So because of that, we can actually simplify and solve by saying y plus 6 equals a value of 5. So once we subtract 6 on either side, and remember too, you can look at your quizzes on the right-hand side in the back of the room. You'll notice that when y equals -1, there were a couple of you that struggled with PEMDAS, right? Right here, this is really a PEMDAS problem. And if that's something of weakness to you, you need to make sure you look over that at some point there, okay? All right, very good. So the next thing, once we solved for y equals -1, we knew that z equals 2 here. We could substitute both in for the top where we could solve for the missing variable of x. So we would get x minus 2 times -1 plus 3 times 2, and all of this would equal positive 9. So -2 times -1 is 2. 3 times 2 being 6. And we get x plus 2 plus 6 equals 9. And then once we keep just simplifying, we recognize that x would be equal to, when I subtract by 8 here, x would be equal to 1. Now, again, I can check this by plugging all three values into any of the three equations, and it should produce the same value, whatever equation was there. If it does, then that checks all the boxes that, in fact, that would be the correct answer. All right, now the next one, as we keep moving, gets much more difficult because now we are trying to simplify three systems to two systems of equations. Now, there's a couple of strategies that you could do, one in which we could actually combine the first and the second to get an equation. So like the first and second equations to get an equation here, right? And then maybe we could combine equations 2 and 3 here And once I did that, maybe I eliminate the x's on both of them. What I could do is then take these two systems of equations and solve them regularly. You could do that. Another way, one that I think I prefer a little bit more, is I take one equation and I use one that's maybe easy to like simplify, and then I start substituting in. So like if I had something that looked like this, maybe an easy part of this would be to isolate x by itself. So if I were to do this, I would get, and again, I'm going towards substitution, at least at the beginning, I might subtract by -3y to get it to the other side. And then I got -x equals -4 minus 3y. And then if I were to divide by this -1 value here, this would actually get me x is equal to 4 plus 3y. Now, once I get this, this is where kind of the new part comes in. Because I get x equals this, I could substitute it in, but I would substitute it in for the other two equations that I didn't isolate. So if I did, I'd plug it in for x for both of these to where equation 1 would be x, which is 4 plus 3y, right? Because I'm substituting that in. And then we would just put what's left over. So we've got -2y plus 3z equals 9. And that would be equation 1. Equation 3, little different because this 2 is in front, would be 2 times x, or 4 plus 3y. And then put the rest of it. So -5y plus 5z equals 17. So with both of these equations, we could actually simplify what is here. So if I were to do that, I would say 3y, and I'll just kind of put it right here. I'll put equation 1. This is the simplified version. 3y minus 2y is y plus 3z. And there's a +4, but I could subtract this 4 to the other side. So there's nothing distributed. So this would equal a value of 5. Now over here, when I distribute, this would be 8 plus, and then 2 times 3 is 3y, 6y. And so you get 6y minus 5y, equation 3, which would be y plus 5z, that's what's left over, equals, and this is where I could subtract 8 right here on both sides. So do it to one side and then the other. So 17 minus 8 gets me 9. And there we go. So these two equations were made by substituting one equation for the other two. And like I said earlier, my goal is to go from 3 systems into 2. If I can do that, then I've been successful for the problem. And then from there, I could do either elimination or substitution. For me, I'm going to, just because I see that both of these are y, I'm going to multiply this bottom one by a negative number, getting me -y minus 5z equals -9. And again, that would be gone, right? So then I could combine the first and the third. The y's would cancel. 3z minus 5z is -2z, and 5 minus 9 is -4. So then I just divide by -2. Notice all of this is the same. It's the big part is getting it to that next equation, right? That's the big thing. So then once z equals 2, I could substitute it in for this one up top, or really either one. But then we would get y plus 3 times 2, because I substitute 2 in for z, and that equals 5. So y plus 6, equals 5. So subtract by 6, and y is equal to -1. Now, I could put either of these two in to find what z is, to find what x is. Because I've already got this equation up here, I could do that. So I would say this would be x equals 4 plus 3 times -1. So 3 times -1 is -3. 4 minus 3 is x equals 1. And that's how I would find the 3 different values. But it all starts by creating 2 equations from what was originally 3. equations and simplifying it that way. Cool? Cool. Let's go to the next one. This is another good one here. I'll give you another strategy just in case you were thinking like, oh man, I want to maybe do something different. I'll go a little quicker through this just so that you can kind of see it. Let's say I was going to combine the first and second and the second and third. In this example, I could actually bring these down if you see it here. So this would be x minus 3y plus z equals 1. And I'm going to combine that with 2x minus y minus 2z equals 2. And then for the second and third one, I'll put 2x minus y minus 2z equals 2. And then the same third one would be on the bottom. Okay. All right. Is everyone Gucci right now? If you're Gucci, say I'm Gucci. I don't care if you're in class or not at home. I hope you are, because from here, I could use either substitution or elimination to simplify to equations. So one thing I can notice is if I eliminate this x here, I want to make sure that the bottom part also has the x eliminated. So if I were to here say, oh, I'm going to multiply by -2, that's fair. This would be, if I put it, I'll put it down below on this one. So if I did that, I get -2x plus 6y minus 2z equals 1. And then once I simplify, the 2's would cancel. -y plus 6y is 5y. -2z minus 2z is -4z. And then this equals 3. Down yonder down here, we could multiply by -2. And when I do that, I get -2x minus 4y plus 6z equals 2. So this one's gone because I've already, basically I'm simplifying by now seeing that I could cancel out these x's like I did up on top. But now I would get a second equation, which is -5y plus 4z equals 4. So the equations that I have now exist here and here because I took 3 and changed it into 2 systems of equations. Which, again, here's the deal. I know that it kind of can take long. I know that that's definitely true. It could take a little bit. But I will tell you that once I get here, it's nothing new, right? So we would have the first equation as 5y minus 4z. And then the second equation would be -4y plus 4z equals 4. I know I could cancel here. Actually could cancel here. So I get 0 equals 7. Is that true? Oh, it's actually not. It's actually not true. And so that's why in this example, I would say that there's actually no solution because it's not true. Now, if it was true, we would say infinite solution in that way. Okay. All righty. See here. All right, so we have a last one before we kind of get to some homework ones. All I wanted to show you here was you could either use elimination, which I did on this one, or substitution with just one equation. But understand the goal is to be able to turn 3 systems into 2 systems. If you kind of get that overarching goal, then you're headed on the right track on that. All right, so let's go over this now. Can you just tell me real quick, in fact, with someone next to you, tell me what you think might be confusing about this one. Go, talk. All right, now you're back with me. Unpause me for a second. The reason is that we have 2 systems with 3 variables. That's a little strange. Normally, we have 2 systems, 2 variables, or 3 systems, 3 variables. Here, much, much different. So here's what we've got to do. In this specific example, we've got to write values in terms of a common value. So, Coach, what are you talking about? Well, let's do this. Let's eliminate the top and bottom with one variable. So maybe -2. So let's say I would eliminate this by going and plugging in -2. So if I did that, I'll put it down below. I would get negative 2x, notice the elimination, plus 4y, again, it's going to each part, minus 2z equals negative 4, okay? So here we are, the x's cancel. Negative y plus 4y is 3y. Negative z minus 2z is negative 3z. And this equals negative 3, okay? So you say, Coach, what in the world, though? I can't solve this. I've got one system with two variables. There's no way that we could solve it. And you'd be exactly right. So let's do this. Let's get y by itself. I chose y. If you chose x or z, you would not be wrong. But let's get y by itself. So to do this, we've got to add 3z to either side. And this would equal 3y equals negative 3 plus 3z. I then divide by 3 on each here. And what I get is y is equal to negative 1 plus z. So this is actually the equation for y. You say, Coach, but what about what do you mean equation? I thought we have to have a value, and you'd be right. But because of this rule up here, we've got to write all of our x, y, and z values in terms of something that is the same. So since this is in terms of z, guess what? Z is going to be equal to z. What that means is that all of our values are just going to be in the same thing, meaning all of them will have the same value of z that's there. So what about x? Well, maybe with x, we could come up here, back to this original one, before we multiplied by 2. And you could see that when I solved for the y and z, I could plug those in for these specific values. So remember that, let's say I isolated x, I could then get this, x minus 2 times negative 1 plus z equals 2. So what we get is x distribute plus 2 minus 2z plus z equals 2. And so combine the z's together to get x plus 2 minus z equals 2. And then we want to get x by itself because notice the y and the z. What does x equal by itself? And that's where I subtract by 2. Those cancel. And then we add by z. So we get x is equal to actually z as well. So because of the fact that there's one less system, one less equation per one less variable, I'm sorry, let me back up. One less equation for the amount of variables we have, we would say that all the values would be in terms of z. So we put the here, here, and here. Now, if you chose x or y, you wouldn't be wrong. But this would just be something that you could do. This could be an answer, but your other values of putting it in terms of x, y, and z would be something you could do as well. All right, let's look at the homework problems real quick. Notice on both of these, or on this one, that we could maybe substitute, might be a good one. Maybe use the middle one to get y by itself, which if I did it, I would subtract negative 5x and negative 2z. We get this, and then we could divide by negative 1 on all these values. And then we could go from there and substitute this. Y equals 5x plus 2z plus 2. We could substitute this in for both of the y's, here and here, and then that's where we could create the two systems. You could also do elimination. That's not wrong, but sometimes there's maybe easier things that you could do with each one. That's what we're looking at. All right, I hope that was helpful for you. I know that if there's any other questions, you could go downward to the bottom of the page that kind of has some podcasts from last year. But the big thing, again, is we want to try to eliminate one equation in order to get the amount of equations to match up to the variables if we can. And when it does, we simply write all of the answers in terms of that common variable, whatever you choose, X, Y, or Z, like we did just a second ago. All right. Hey, as we kind of go to the next section, this next section is a good one. If you are on Monday and you're watching just 7.3a, you are done for the day. Go ahead and attack some of the homework problems that are there. But you'll notice that some of them you won't be able to do because right now we're going to go into section 7.3b. We're going to discuss something called a matrix. We're going to use matrices to be able to solve systems of equations and show you how we would solve those there. Okay, so you could pause me, or once you get done with the first part, you could pick me up with this one tomorrow. So here we go. We're going to keep it rolling. Same kind of concept here. We're going to make sure that we know how to do a specific matrix. All right, let's do this thing. All right, on this one, this is a homework problem from online. Be sure that you can maybe isolate this third one. I'm just trying to give you a heads up on maybe how to start it. But you could isolate that third one, plug it into the first and second in order to attack and solve for the systems of three equations there. All right, so on this x, y, and z, what do we do if we wanted to solve all of this via calculator? That's a good question. How can I solve this using a calculator? Now, understand that what we're going to look at, matrices can be used for a whole lot, okay? Some of you have watched The Matrix before, and so you have an idea of what we're talking about. This whole idea of matrices kind of running the world and creating pieces of technology that are far more advanced than maybe what we even have today. But let's do this. Let's go into matrices. A couple things you need to know before we go into this on this short lesson is the fact that when we solve for a matrix, we have a matrix that is m by n, which means how many rows by how many columns. So if I were to look over, let's see here, over here on this one, if I said what is the, how do we describe this matrix? We would say it's a matrix that has 3 rows and 4 columns, right? So 1, 2, 3 rows and 4 columns. So we would say the order of that would be a 3 by 4. Hope that makes sense. And that's how we kind of solve it. Now, using this, we can put it into a specific form and really maneuver it. Some of you will do more of this in college, but you could maneuver it. And when maneuvering it, you would be able to solve for that systems of equation. So take, for instance, number 16. 16, you could definitely do 3 systems of equations by maybe substituting or getting x, y, or z by itself and then substituting it in for the third, just like we did the other day. But there's also a way that you could actually plug this into your calculator to be able to solve for a systems of equation. And it's called using a matrix capability. So how do I do this, Coach? How does this happen? Let me take you down the journey together, all right? I'm going to throw this calculator up here. While it's coming up, you'll want to make sure that you, as you study, you'll need to know systems of equations, both 2 and 3. And then you'll also need to remember how to use elimination, substitution, and specifically the word problem. So just as a reminder there. All right, it's coming. All right, let's look at one systems of equations that has 3 equations and 3 variables. One we were just doing. Let's see if we can. All right, let's see here. All right, let's knock me off. So this right here is an example of a systems of equations that is a 3 by 4, meaning we have 3 rows, and obviously you could see 3, but there's going to be a 4th column over here. Now, in doing this, we could go to what we call row reduced echelon form. Say, Coach, what is that? It's a method that we use in order to simplify a matrices or systems of equation to be able to allow us to solve. So let's say we were to, I'm going to open this up. There you are. All right, let's go to stat here. And let's go to, oh, I'm sorry, hold up, not stat. Right here. Do you see this? X to the negative first. Right above it is this blue thing called matrix. Go to second matrix. All right, and you're going to notice that over on, let me make sure I got it. Boom. So, okay, second matrix. And if you've got something over here, you'll notice that it's a 3x3. You're probably going to want to get rid of that. So for me, if I press enter, that would be A, and I could, press enter here, and it could give me what the actual matrices is. Okay, go back there to second x to the negative first again, and let's go to edit, and let's try to see if we can actually edit this thing. Now, when we solve for systems of equations using a matrix capability, I'm going to go for the first systems of equation at the top. So it's going to be all the x's are going to be downward, all the y's are going to be downward, the z's, and then finally the solutions. So technically, what this is it's a three rows, but there's 3 x, y, z, but there's also a solution. So this is actually a 3 by 4. All right, so that's how we're going to do it. So remember, the first equation when looking at this is, pull it up here, 2x plus y minus z equals negative 3. 2x plus y minus z equals negative 3. So we're only putting the coefficients in here. So we're going to put a 2 in for that. The y comes next. We get a positive 1. Next one is negative 1. And then the solution is equal negative 1. And then the next one, negative 3, I believe. Let me see. Good. The next one's 4x minus y plus z equals 6. So we're going to put that in. Oh, raise this up. You raise me up so I can stand on mountains. You raise me up. All right, we're going to the next one. The last final one would be this one across. So notice I've got equation, get this here. Yeah, we got it. Equation 1's on the top, equation 2, and equation 3. So once I solve for this, I'm just going to kind of go to second, quit, and I'm going to go back to second x to the negative first. And we're going to go to the math button. So everything we do with matrices is on second matrix. And we're going to go downward to our ref, which is the simplified version of this. So it's trying to simplify what my matrices is. So go down to second x to the negative first again, press A, and there we go. So what we got now is 1.5, 1, negative 3.6, 1.4. But remember that right in here, this was all of the x's that were there. And if there was something that was missing, it would behoove you to put in a 0, and that way it fills that spot still. So what we have now is this. If we read it across, the 3 equations are x plus 0y plus 0z equals 0.5, or rather, x is equal to 0.5. Now the next one, because it's in the second column, is y. Therefore, y is equal to negative 3.6. So again, we said y is equal to negative 3.6. And then finally, z is equal to 0.4. And that's how we would write it there. Okay. Let me show you a different one. Let's see, and then this is our practice here. Okay, let me show you this one. Let's see. All right, I want to look at this one. Well, really both of these. By the way, this one up here, this would be 4 rows. So the order, by the way, order just means the rows by columns. So what is it? There are 1, 2, 3, 4 rows. And the columns that you would have would be x's, Y's, Z's, W's, that's 4, plus the values that are on the right side, so that's 5. So this is a 4 by 5. And then you could just plug it in your calculator. So when I go to matrices, I would state from up here, it'd be 1, 1, 1, 1, 4. The next one would be 3, negative 2, 2. Notice this is the second one, right? 1, positive 7, and then so on and so forth, okay? That's how you would attack it. The bottom one, though, much different, has X. Well, let's put down what you've got here. You've got 1X, 1Y, 1Z, and a 0. On the second one, I have a 2, a 3, a 1, and a 0. Again, it's very important that these are all X's, these are all Y's, and these are all Z's. And if for some reason something skipped, please fill it in with a 0. Okay, fill it in with a 0. Now, in my calculator, I'll do this one more time, and that way you could kind of see it. See it. Hope you're, if you're a Georgia fan, I apologize. I thought y'all had it the other day, by the way. Second X to the negative first. Again, you'll see that matrix. Go ahead to edit. So it'd be